This video will examine Tesla's new master plan, which paves the path for a future free of fossil fuels. It will also highlight the three main components of the plan: electric automobiles, heat pumps, solar energy generation, and battery storage. Be ready to witness the dawn of a new era in sustainable energy, as we specifically focus on heat pumps and how they work. We'll also examine Tesla's innovative approach to using heat pumps in their electric vehicles. First things first, make sure you subscribe to our channel and give this video a big thumbs up. Then, sit back, relax, and let's get started. Tesla has always been committed to accelerating the global transition to sustainable energy. And now in part 3 of its master plan, the company has identified 3 key foundations to accomplish this aim. Electric cars make up these pillars. Elon Musk and his colleagues at Tesla believe that heat pumps for residential and commercial use will become widely used, along with solar power generation, battery storage, and heat pumps. In terms of cutting back on the use of fossil fuels, heat sources will be equally as influential as electric cars. The new master plan is essentially a roadmap for a sustainable future in which all fossil fuel dependency is abolished. In order to do this, we must cease burning everything, including coal and gasoline for energy, natural gas eventually, and diesel. In order to completely switch to sustainable energy, we must swap out our gas heaters and stoves for greener. The impact of alternatives, such as electric heat pumps, is noteworthy. According to the master plan, switching to electric vehicles worldwide will cut fossil fuel consumption by 21%, while switching entirely to heat pumps will cut consumption by 22%. Furthermore, the cost of investment for switching to heat pumps is only $0.3 trillion, whereas switching to battery-powered electric vehicles will cost $7 trillion. What exactly is a heat pump, and how does it operate? Heat pumps are highly efficient electric heaters that transfer heat from the outside of your home to the inside. They are perfect for heating both houses and businesses, since they don't produce heat themselves. Rather, they just gather it from the outside. Although this can seem contradictory according to experts, the difference in temperature between the water in a pool and a person's body is higher than normal. However, the longer they spend in the pool, the greater the difference in energy, and the greater the sensation of hot or cold. The second rule of thermodynamics, which states that heat always goes towards cold, and that energy always flows from higher densities to lower densities, supports the theory that cold dissipates because the heat energy in their bodies equals the energy in the water. Heat pumps utilize this natural law to their advantage by transferring energy from the exterior of the house to the interior. Instead of pumping heat, heat pumps pump refrigerant, which is a liquid with a very low boiling point that vaporizes at room temperature. In the past, refrigerants caused environmental harm by breaching the ozone layer, but more recent refrigerants, like R134A, do not cause the same harm. The heat pump's moving component, the compressor, compresses the vaporized refrigerant to raise the temperature and energy density. After that, a wall-mounted blower system, with a fan that circulates room temperature air over a hot gas coil, is used to pump the heated gas inside the home. In order for the refrigerant to do its next task, it must cool down even further. To do this, it passes through an expansion valve, which quickly lowers pressure and lowers the temperature until the chemical is once again liquid, usually around -20 degrees Fahrenheit or -30 degrees Celsius. The heat energy from the compressed gas follows the airflow into the room. The extremely cold liquid is subsequently pumped to the heat pump's exterior coil, where it absorbs heat from the surrounding air. The refrigerant absorbs heat from the surrounding air, rises in temperature, boils into a gas, and is then compressed to even higher temperatures before being pumped into the home by Tesla, which debuted their first heat pump with the Model Y in 2020. Previously, they used electric resistive heating, which uses low efficiency to heat an automobile, transfers energy from the battery into the metal coil. With the Model Y from Tesla, the company has adopted a different strategy from most other electric cars, which uses resistive heating methods that consume a lot of energy and reduce vehicle range. Instead, the heat pump uses a refrigerant that rapidly compresses and decompresses, increasing and decreasing in temperature. The heat energy from this process is then transferred into the cabin via a wall-mounted blower system. This highly effective system only requires 10 individual components and 6.3 meters of hose, which is significantly simpler and more efficient than the 35 components and 18.4 meters of hose used in the Ford Mustang Mach-E's heat pump system. The circuit board design, which integrates all required parts and connectors into a single unit, served as an inspiration for Tesla's engineers. They aim to apply this idea to the heat pump design, compacting the complete thermal system into a single unit that is about the size of a basketball. The idea that electric vehicles can't operate in cold locations has been debunked thanks to this creative method of warming the cabin of an electric vehicle. It's hardly surprising that other manufacturers are finding it difficult to compete with Tesla given its dedication to efficiency and innovation, as demonstrated by the Model Y's heat pump. The way we think about heating and cooling in electric vehicles is being revolutionized by Tesla's innovative and effective heat pump. Tesla's heat pump design solves this problem and is noticeably more efficient than competing models. The resistance of the metal used in the system concentrates energy, increasing the temperature, and a fan blows cool air over the metal coil, resulting in the hot air being directed towards the car's cabin, increasing the suitability of electric vehicles in cold areas. The octal valve, a small and effective thermal system, the size of a basketball, that enables the heat pump to operate in reverse and does away with the need for separate heating and cooling units, was created by Tesla's engineers after being inspired by the design of a circuit board. They have since created a completely automated heat pump production system with a 99.995 success rate and great quality, which enables them to create a super manifold every 7 seconds. The way we heat and cool our houses could be revolutionized by Tesla's indicated development of a home HVAC system that uses the same heat pump concept as its electric automobiles. Elon Musk has stated that the existing heat pump design can be expanded to heat a home or even a business, and that the HVAC industry may undergo changes if Tesla is able to produce heat pumps with the same level of efficiency and manufacturing scale at larger sizes. The Tesla heat pump system is a groundbreaking innovation that could transform how we heat and cool our homes and cars. With Tesla's dedication to innovation and environmental responsibility, the company's distinctive design and completely automated manufacturing system are raising the bar in the industry. As a result, they may be the ones to pioneer the transition to heat pumps. Heat pumps are a critical component of Tesla's new master plan, which aims to reduce the use of fossil fuels and expedite the global energy transition. By implementing heat pumps for residential and commercial heating, we can break free from our reliance on natural gas and build a sustainable future that will provide more than enough energy to power our global civilization. We appreciate you watching our movie about Tesla's new sustainable future master plan. As we've seen, heat pumps are being adopted for just as important as switching to electric cars, and consuming less fossil fuels is the heating of homes and businesses. Tesla's dedication to efficiency and innovation is seen in its creative use of a highly efficient heat pump for heating and cooling. It's not surprising that rival producers are finding it difficult to match their groundbreaking concepts. Please click the like and subscribe buttons. Show your support for a sustainable future, and we'll see you in the next film. Thank you. Let's work together to create a cleaner, greener world once more.